Hi everyone, and thank you for joining me today. A while ago, I told you about an experiment where we compared physical versus virtual manipulatives and how they affect learning. My student Joel and I conducted another experiment that builds on those earlier results. We contrasted two types of physical manipulatives that were designed so that students had to move their hands differently, either in a way that draws their attention to the relevant visual part of the manipulative, or in a way that creates a hand gesture that aligns with the concepts they were learning. As an example, this is an energy diagram. I won't go into details, but you can think of it as a way of showing energy levels of electrons within atoms. Electrons are shown with these small arrows, and students place the electrons on the diagram. One concept students were learning was that electrons that are shown at the same height have the same energy levels. So, in one version of the manipulative, students were instructed to move their hands up and down when placing the electrons on the diagram. This is meant to draw their attention to the height of the place where they're placing the electrons. Alternatively, students were instructed to move their hands sideways. So the sideways movement is similar to gestures we use to show that something is equal. And then we constructed two versions of a virtual manipulative where students either had to move their mouse vertically or sideways when placing electrons in the diagram. So this was a fairly simple manipulation. This is all that differed between the two versions of the physical and the two versions of the virtual manipulative. And we assigned students to work with different sequences of these different manipulatives and tested their knowledge of the various concepts they learned before and after. And we also tested the mistakes that they made while working with the manipulatives. The various concepts students learned had either to do with the height of the electrons on the diagram or with the electrons themselves. So when the concept had to do with the height of the electrons on the diagram, we thought that the physical experience of the height and the effort associated in lifting your arm might actually benefit students' learning because it gives students a haptic experience of the concept. That is, they can feel the concept of energy with their body movement. By contrast, when the concept had to do with the electrons themselves, there was no physical experience to relate to because the concept itself was more abstract. What we found is that when the concept had to do with the height of the electrons on the diagram, students benefited most from working with physical manipulatives first, regardless of how the manipulative was designed. So, if students first worked with a physical manipulative and then with a virtual manipulative, their learning outcomes were higher compared to students who first worked with a virtual manipulative and then with a physical manipulative. However, when the concept was more abstract and had to do with the electrons themselves, we found a slight advantage of working with manipulatives that made students gesture in ways that aligned with the concept. And I say slight advantage because we only found that these students made fewer errors while working with the manipulatives, but there were no differences in terms of learning outcomes. So we believe that these results suggest that it's really the haptic experiences that matter when students first work with a manipulative. In other words, it seems important that when students start to work with manipulatives, that they're able to experience through their body what they're learning. And we're just about to start a follow-up study on this, so stay tuned for more results, which I'll share with you when we get them. Thank you for listening.